All right, your favorite real world problems. So we're going to use factoring to solve a real world problem. A museum vault has an outer steel wall with a uniform width of X. When they say uniform width, that means that it's X units, kind of like those picture frames we've seen, going all around. That width is X units long. Well, I guess feet. We're in feet right here. The area of the museum vault ceiling and the outer steel wall is 1,664 feet squared. So that's the total area of the whole thing. What is the width of the outer steel wall? So they want us to figure out what X is. Because they gave us an area measurement and we're dealing with a rectangular shape, we can just use our formula. Area is equal to length times width. So they gave us the area of 1,664. So we're going to substitute that in for our area. Now the length and the width, we have to figure out what that is. Our length right here is 40. We're adding on an X and adding on another X. So the whole thing has two of those X's plus the 40. So our length is 2x plus 40. Our width is going to be 20 feet, but then we're adding on an X and we're adding on an X for that steel. So that's going to be two of those X's plus the 20. Solve for X. So it looks like we have factored form right now, but this equation is not set equal to 0, so I can't set each factor equal to 0 using the zero product property. But what we can do is multiply everything out, get it into standard form where it is set equal to 0, and then think about what factoring we might be able to do. So let's do a little bit of multiplying. That 1664 stays there for now. We're going to distribute our 2x. 2x times 2x is 4x squared. 2x times 20 is 40x. Now let's distribute our 40. 40 times 2x is 80x, and 40 times 20 is 800. So standard form, we want our equation set equal to 0. I'm going to subtract this 1664. And over here, I've got a like term on the end. I'm going to subtract it from that 800. That gets us our 0 equals. Now, you may have noticed we have like terms that we can combine. I was just waiting to rewrite it one final time and combine those like terms right now. So 4x squared, 40x plus 80x is 120x. And then 800 minus 1,664 is a negative 864. All right, so we have our equation in standard form set equal to 0. Because we have an x squared and an x, we have to change our solving method, and we are working on solving by factoring in this lesson. So we go to our x squared term, and we notice there's a 4 in front of the x squared. So we can't just go to factors of negative 864 that add up to 120. We won't find any. This 4 is an issue. Now, first thing you can try, because you're working with an equation, can we divide this side of the equation by 4 and this side of the equation by 4? Well, 0 can divide by anything, so that's not the issue. But the question is, do these three terms all divide by 4? And lucky for us, they do. So this really helps us out when we're trying to factor and you have an equation, because if you're going to divide by 4, you have to divide the other side of your equal sign by 4. 0 divided by 4 is 0, and then each of these terms gets divided by 4. 4x squared divided by 4 is just x squared. We like that that's just an x squared. 120x divided by 4 is 30x, and negative 864 divided by 4 is negative 216. Now we have an x squared term. We can find factors of negative 216 that add up to positive 30. I don't know about you guys, but I don't know the factors of negative 216 off the top of my head. Honestly, I would just grab a calculator and start dividing. We know 1 is going to fit in 216 times. Because it's a negative 216, we need a negative factor. Should the smaller factors be negative or the larger factors be negative? Look at your b value. The larger factors will have the same sign as your b value because your b value is positive. We want positive larger factors, so I'm going to make all my small factors negative. All right, negative 1 and 216 do not add up to 30, so we're going to keep going. 2, but I'm going to make the smaller factor negative, and 108, that does not add up to 30. 3 is a factor, negative 372, that one doesn't work. 4 is a factor, negative 4 and 54. If we add those, we get 50. We're actually getting closer to the 30. We're just not quite there yet. 5 is not going to be a factor. 6 is a factor, negative 6 and 36. And there it is. Negative 6 plus 36 is 30. So let's write this in factored form. 0 equals x minus 6 times x plus 30. Set each factor equal to 0 and solve, and that should be a 36, I meant to say. Look at me catching my own mistake. Now, mathematically, when we solve, we're getting 2 answers. Our quadratic equations have 2 answers. We're going to add 6 to both sides. We're going to subtract 36 from both sides. Now, the thing is, when you have context to the problem, we're not talking about just a random mathematical equation. This x represents something. So we have to look at our picture. It represents the steel wall, the width of the steel wall. Do both of these answers make sense? And really, this is the one we want to focus on. Can you have a steel wall that has a measurement of negative 36 feet? No, we do not measure in negative numbers, so we're going to cross off the negative 36, and we know that x equals 6, and what that tells us is that the width of the steel wall is 6 feet.